Okay, so this is video 2 of how to solve problems for beginner programmers, and we are applying the 5-step strategy that we learned in our earlier video to solve the Caesar cipher problem. Okay. So step 1 was to say the problem out loud so that I'm sure that I understand the problem. And so saying out loud to myself is to sort of tell myself or somebody else what the problem is asking me to do. So essentially the problem is asking me to encode, decode a given message, encode or decode, and basically I'm going to get a user input, right? And the user input will decide whether I want to encode a message or decode a message, right? So that will decide encode, decode, or quit, right? So there are 3 things that I need to do. If I'm encoding, there are a certain set of rules, right? Based on a rotating or a shifting number. So a number will be provided to me, and based on that, I'll encode or shift each letter. In case of decoding, there are other set of rules, so I'll be given an input string, and I'll also be given another word. So based on that word, I have to find how much shifting was done for that particular string, which is an encoded message. And for quit, just stop the program. So I said the problem out loud to myself, and then I'll move on to the solution. Notice in this video, I'll talk about how to do encoding, and I'll leave decoding for you to try with the similar steps that I'm following right now to basically fill in these 5 steps of strategy and arrive at the solution to the decode part. Okay. As I said, I'll work through the encoding part and leave the decoding part to you. So here I'm supposed to write down the steps, right? So step 1, I think, is to continuously ask the user. So essentially, I'm telling the solution to my computer in English, right? Continuously ask the user for E, encoding, decoding, or Q, right? So this is 1. Then the second instruction based on user input, right? Go ahead and perform some actions, right? So perform some actions basically described below, right? And as I said, you'll have 3 sections for this. So if the input, so step 1, if input is E, I have to do something, right? So there will be 2 more. So if input is D, then do something. So I'm leaving that for you. And the third one is going to be if input is Q, stop the prompting process, right? So this is that. Now I'll go on inside. If the input is E, then do the following, right? So do the following. What should I do then? Right? So if the user asked me to encode, then obviously I'll have to go and ask the user again, right? So go and ask the user for the message, right? And the number, right? The rotating number. So it is going to be an integer. So ask for the number, which is going to be an integer, and ask about the string, right? Which is going to decide how much shifting we need to do. Now, based on the value of the number, find its equivalent in the rotated shifted string. So maybe have somewhere here, maybe have the rotated string ready first, right? So have the rotated or shifted string ready, because this is what we did when we were talking about a word, right? How this got converted to an encoding message. So have the rotated or shifted string ready, right? And maybe like these are sub steps, so I'll just like indicate them with arrows. Have the rotated this thing ready, and then based on the value of the integer or the number, find its equivalent in this rotated string, right? So based on the integer value, based on, obviously the rotated string was created because of the integer value, right? So I'll not say based on the integer value, but basically based on, yeah, like find the equivalent. Maybe I'll just write find the equivalent of each element in the input string from the rotated one. right? So from the rotated one, I'm going to grab the corresponding. So just like we did with that example with this, right? So for T, the corresponding element was W. For H, the corresponding element was, I don't remember, V or something like that, right? So go and pick those elements, right? And based on that, maybe put these elements, keep putting these elements together. So this means maybe we need a loop here, right? So just like I'm commenting here, maybe we might need a loop here. Just for my own reference, it's up to you how you want to write these steps down. So keep adding these equivalent elements to a string maybe, right? So I can do that. And this is the string that we'll output. So this is going to be my output. So just go ahead and output that string then finally, once you're done finding all the equivalent ones, right? So I have the step 2 in my strategy ready. And as I said, similar to the encoding one, you should go ahead and fill the decoding one as well. We already have for the Q, right? So if you remember, step 3 begins with refining these steps that I have, like, because these are like pretty crude if you think about them, right? So let's actually begin with an example, right? And maybe like if I look at each of these, so step 1 was asking the user for EDQ. Oops, I'm going backwards. So instead of step 1, maybe have a more concrete statement saying that have a while loop, right? That asks for the prompt, right? So maybe I can do that. So that's going to be my step 1. Let's go back and see step 2. Based on the user input, if it's E, so because that's what we are focusing on right now, ask the user for, okay, so good. So here, 2 input statements, right? So 2 input statements for E, right? For encoding, 2 input statements. One will ask for the string, right? The other one will ask for the number, right? Then the third step is going to be, what did I say? Find the equivalent of each element. So basically have the rotated shifted string ready. So we need to have the shifted string here, right? So maybe using list indexing or slicing, right? Because just imagine list or string indexing rather, right? It's working with strings here. As I can tell, the user is going to enter a string, right? Using list string indexing or some way, right? Have the rotated string ready, right? So have the rotated or shifted string ready, right? So maybe I can use an indexing or some way of shifting using that number, right? Okay, let's go back. So I have that ready already, right? And then find the equivalent of each element in the input. So how do we do that, right? Obviously, there are multiple ways of doing it. Like one way is go through the letters of the string, find its index in the original alphabet. Okay, so let me convert that here, right? So go through all letters of string, my input string I'm talking about, right? And find the index of these in the original alphabet. So basically I should have the original alphabet even before we begin, right? So have the original alphabet as a string here, right? So look, I refined it and I found that I was missing this step. So I have the original alphabet, go and find the letters, each letter of the string in the original alphabet. I'm calling it OA. So go and find the letters of the string in the original alphabet and find their index. So remember, we can use a lot of techniques in Python like dot index, for instance, right? And then once you have the index for each of these letters, so let's say the word was this, right? The index in the original alphabet for this was, I don't remember, maybe 19, right? So I'll have that. And then I'll go and check, or maybe this is going to be a subset, right? Substep. Go and check in the rotated string, right? Go and check in the rotated string what element is at position 19, right? For example, at 19 there is W, right? So add this W to an empty string, right? And then keep adding like every element as we keep getting the element as we are looping through. So this kind of suggests that we need a loop here, right? As we are scanning through each letter of the string, First, I'll go and check the original alphabet, use a dot index or something, find the position, and then find the corresponding element in my rotated string and keep doing that, right? Okay, one thing that comes to my mind while I'm refining these steps is, what if that alphabet, let's say somebody gave me this and then at the rate, right? So this is not in the alphabet, but this can be an input, right? So we have to think about cases like these. So maybe even before like scanning here, right? Maybe I need to check if it exists in the alphabet or not. If it does not, just keep it as it is, because that's what my problem is asking me to do. Keep it as it is. If you get something like this at the rate, and then if you get something like uppercase something, keep these things as they are, right? So add that aspect as well here somewhere. Okay, so as you can tell, we are almost ready to write our pseudocode. And pseudocode is essentially nothing but converting these like steps into a more formalized way of representing this, so that writing code becomes easier, right? So I'll not take a lot of time here. I'll simply write create alphabet. So create string and alphabet. So I'll just write that alphabet, and then take user input. So this is, I'm talking about Q, E, or D, right? And then while input is not equal to Q, keep checking. If input equals E, then we'll do something. If input equals D, then you'll put your steps here, right? So if input equals E, a prompt user for string. So I'm not writing the complete thing. Input string, right? Input integer, create rotated string, right? And check if the letter exists. Scan through the string, not enough space. Scan through string, right? If letter exists, then do something else. Just add it to, let's say that like I'll create some like empty string called s here, and then else s equals whatever that element is, that element plus that empty s, which is like it's going to be s, right? If letter exists, then find the rotated part. I should have more space essentially here, but that kind of gives you an idea of how you can convert it, right? So maybe like even here you can write more detail if you have like more space and more time. Write in detail here. If yes, then get the index from the alphabet, find the corresponding letter in the shifted alphabet, append it to an output string, which is s in my case, and that's it, right? But if not found, still append it like we did here, right? So that's the goal of our exercise. And having done that, now finally we are at step 5. Now you'll go to your IDE, which is obviously Spider in our case. So let's go there, right? And now I'm converting each and everything to my code, right? So essentially all I have to do is like each line will be converted to your actual code, right? So response, ask the user to enter whatever you want to enter. So ask the user to enter Q, E, or D. You can obviously write it like more refined in the sense like Q is for quit, E is for encode, D is for decode, right? And then obviously you should have a while statement here that will check whether if the user entered Q, quit. If the user did not enter Q, then you will write something like while response not equals Q, keep doing things, right? So you should have this statement once you have the decoding part as well, because I don't have it. So I'm just like writing the if statement here, right? So I'm saying if response equals encode, and basically if you look at it, I'm converting my pseudocode to actual code now, like line by line, exactly line by line. If this is this, then go and get the string, if you remember, right? So string, maybe I can say input, enter string, right? And here rotate So rotate is that number. So maybe I can say int input. Obviously, it should be converted to an integer, right? And enter integer. And okay, so I have this. What I need to do is, if like we forgot, we need to have the alphabet already ready, right? So we figured that out while we were writing a pseudocode. So alphabet is going to be a string of A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, right? And based on the integer, I'm going to create my new rotated or new alphabet, right? So I'm calling it new alpha, right? And here I'm simply using my indexing and slicing knowledge. So all I have to do is, based on the value of my rotate, I'm going to shift my alphabet. So the first part is going to be wherever rotate begins, right, until the end, and then append those three, or for example, if the rotate value is 3, append those elements at the end, right? So that's what I'm doing here. So append those elements at the end, which is up to rotate. Just split the alpha, actually. That's what we're doing here. So I created the new alpha. Okay, this is not alpha, but alphabet. Let's name it alpha. Easier, right? And then we come to our if part. So if you remember from our pseudocode, right, we are done with all of this, right? Create string, user input. While obviously you need to add it later on, but we are working with this if part. So we created the rotated string. Now start scanning through the string. Okay, so to scan through the string, we have to do a for loop. But remember, I also created an empty string to which I'll append the the encoded message, right? So here I'll say for variable in string, right? Go and scan through every element. And if, remember, we also have to check whether it's there or not in the alphabet. So if it is in alpha, again, I'm converting everything line by line, right? Go and add or go and create this variable called index and get the index of that alphabet. So alpha dot index, and index of what? Index of L in alpha, right? So this is how we use the dot index method. And then finally in the output, plus equals new alpha, that's the name of the string, right? Add the new alpha and the position of that element that's at the position index, whatever that index is, right? And if L is in alpha, that's fine. If it is not, what are we supposed to do? We have to keep it as it is. So just keep it as it is. So output plus equals L, right? And then obviously come out of the for loop once you're done with the entire string and print. This is my encoded message, right? So encoded message is, and obviously that's going to be the output. So what we did here, and then obviously you can add an else for this if to do the decoding part, and then finally we'll have with the while statement, we'll take care of the fact that if some user enters a queue, then obviously we can get make the loop stop. Otherwise, we have to keep prompting the user to enter the response. Right? Now, the next step, once you're done writing your code, is to go and test it with different values, right? So, for instance, here, and like keep refining it with your test cases. So, for instance, here, obviously, I have only E. So enter the string. This, notice, take care of the spaces here, right? Enter the integer 3, and we get this encoded message, right? So, similar to that. Okay, so I didn't write the entire alphabet. That's okay. P Q R S T U V W X Y Z. So that's good. I figured that this is not the one that we just went through, right? Obviously, I need some space here, right? So make sure you have a good way of asking, right? So we get that encoded message. And as I said, enter some spaces here. Keep refining your code now and keep testing it for different test cases now. So this is the entire process of working on a problem and arriving at a solution, right? So go ahead and debug it, go ahead and refine it, go ahead and do it, test it for difficult test cases. And this is an important step that we added only for the encoding part, because you should go ahead in smaller chunks even when you start writing your program. So this is again part of the strategy. Okay, so with this, I end this video. Hopefully, this will be useful for most of the beginner level programmers in solving problems.